All right, when we add terms, they must be like terms, and we don't change exponents. We don't change exponents. So we're just combining our like terms that we've seen before. So for an example, if we have 3m squared plus 5m squared, these are like terms because they both have the squared on them, and they're both m's. So we just combine them. 3m squared and 5m squared gives me 8m squared. I don't change the exponents when I'm adding or subtracting. All right, you're going to go ahead and do these 3 examples. Check them with a key and then come back. All right, the next one, when we multiply terms, we multiply coefficients, which I'll write on the table. So in that second blank, we multiply coefficients, but you add exponents on the variables. So when we're multiplying, you multiply the coefficients, the number in the front, but you add the exponents on the variables. So now we don't need like terms because this is one big term right here because we're multiplying. So I'm going to multiply my coefficient. 6 times 2 gives me 12. And then g to the 4th times g to the 3rd, I'm going to add these exponents to get g to the 7th. So now come back and do these 3 examples, and then check it with the key, and then come back. Part C, when we're multiplying a monomial, one term, by a polynomial, multiple terms, it's just distributing. You just have to keep in mind, since we're multiplying, we must add the exponents. So on our example over here, 4x squared times 2x plus 3, I'm just going to do my distributing. You may want to remember that if there's not an exponent, there's a 1. You may want to write that. It might be helpful because now we need to add our exponents with our multiplying. So 4x squared times 2x, well, 4 times 2 is 8. And then x squared and x, 2 and 1, x to the 3rd. And then 4x squared times 3, 4 times 3 is 12. X squared, well, there's nothing to change it, so keeps x squared. Come back and try these 2, check it with the key, and then continue with part D. All right, now if we want to multiply a polynomial by a polynomial, so a multi-term times a multi-term, that means every term in the first polynomial needs to times by every term in the second. So in this example, everything here, both of these, will multiply by everything here, both of these. So to do that, the easiest method is what we call either the area or the box method. We call it that because you're going to start by drawing a rectangle and then essentially finding the area, which is just length times width for each of the boxes, and then adding them together and combining like terms. So in our example, what you're going to do, you're going to start with drawing a box. Then you're going to split this box up based on how many terms are in this parentheses and how many are in this one. So there are 2 terms here, 1, 2. So I need to split this up into 2 parts. And there are 2 terms here, so I need to split the side up into 2 parts. Then from this parenthesis, I'm going to take the first term, and it goes on top of the first box. And the second term goes on top of the second box. Next set of parentheses goes along the side over here. First term next to the first box, and second term next to the second box. Go ahead and get that copied down on your example, and then we're going to do our multiplying. So now to find each box, what we're going to do is we're going to find the area, which is just taking its length times its width. You may want to remember that there's a 1 and a 1 for the exponents. So this box has x and x for its side lengths. So x to the first times x to the first gives me x squared, because 1 and 1 is 2. This box has a side that's 3. This side is the same as this side, which was x. So I'm going to do 3 times x, which is 3x. It may be beneficial to bring down this plus sign so that you remember it's positive. This now has a side of 4, and then this side matches this side, which was x. So x times 4, 4x. And once again, you may want to drop down this plus sign to remember it's positive. Then the last box has this side, which is 3, and this side, which is 4. So 3 times 4 is 12. And positive, bring down this positive. Now, the entire box, this entire rectangle, is our area. So what you're going to do is you're going to combine like terms. We have an x squared, no like term, so x squared. I have a 3x, well, and 4x is a like term, so these two need to get combined. 3x plus 4x, 7x. Remember, adding, we don't change the exponents. And then plus 12. And there's your answer. Then you're going to try this next one on your own. Notice now you have a 3 by a 2. That's why there's 3 boxes and then 2 boxes. Try that one, check it with the key, and then come back. All right, now if we have a monomial times a polynomial times a polynomial. So one term, multi-term, multi-term. One term, multi-term, multi-term. You're going to distribute first to just the first set of parentheses. Then you're going to use your box method. Okay, so I have an example here. I'm going to put little ones on all of these so I remember their exponents are ones. You're going to start by distributing this to the first set of parentheses only. So 2x times x, 2x squared, because 1 and 1 is 2. 2x times 1 is 2x. This one doesn't change. I'm going to put a little 1 here. Just bring it down. Now you have a 2 term by a 2 term, you're going to make your box. You would put 2x squared plus 2x to the first, and then on the side, x to the first plus 3. 2x squared times x to the first is 2x to the third, because 1 and 2 is 3. X to the first times 2x to the first is 2x to the second, because 1 and 1 is 2. 2x squared times 3 is 6x squared, because squared but nothing to change it. And then 2x to the first times 3 is 6x to the first, because 1 but nothing to change it. Then we're going to look for like terms. So I have 2x cubed, no like terms. 2x squared and 6x squared, those are both positive. So 2x squared and 6x squared is 8x squared. Remember, we don't change the exponents when we're adding. And then our 6x to the first, or just 6x. And there's your answer. So distribute to the first set of parentheses only, leave the second one alone, make a box. When we're squaring something, what does that mean? What does it mean if I say I want to do 5 squared, or 3 squared, 17 squared? What does that mean to square something? Well, if you didn't know, it means to times something by itself, or multiply by itself. So in this example I have up here, I have x plus 3 squared. Well, what that means is I'm going to take x plus 3 and I'm going to times it by itself. Well, now look, I have a 2 term by a 2 term, so now you're just going to make a box. You'd make your box. I'm not going to run through this whole thing. I'm going to do x plus 3 on the top, also x plus 3 on the side, get all 4, add them all up. Okay, so if you square something, it means times it by itself, you still need to make a box. All right, the last example here, we're going to go through this whole one together. If you want to try it on your own, you can, and then come back and see if you got it right. If you have some addition or subtraction with polynomials as well as multiplication, you need to make sure you follow PEMDAS. So parentheses, exponents, multiply and divide, add or subtract. Parentheses, remember, means to simplify anything on the inside of the parentheses. So I have parentheses, but I can't simplify. 2n plus 3, nothing happens. I have parentheses, but 4n minus 1, nothing happens. I have parentheses, but 5n minus 6, nothing happens. So I move on from there. Exponents. I don't have any exponents to deal with. If I had an exponent, it would be if I had something like this, where I would need to remember times it by itself, make a box. Okay, but I don't have any of that. So I go into multiplying and dividing, which I definitely have multiplying and dividing. So what we're going to do, see this plus sign on the outside of the parentheses. That kind of separates it so that this is multiplication I need to take care of right here. Look, 2 term by 2 term, I'm going to make a box. You would simplify this one first. Then I can do 2 options. I can either distribute, like you saw on the front side, or you can make a 1 by 2 box, your choice. So you're going to start with simplifying this one. If you want to try it on your own, go ahead and do that, and then come back and see if you got it right. Otherwise, watch and we'll do it together. So 2 by 2. We're going to put 2n to the first plus 3, and then 4n to the first minus 1. 4n times 2n is 8n squared. 4n times 3 is 12n. Negative 1 times 2n is negative 2n. And negative 1 times 3 is negative 3. So I have 8n squared. I'm going to combine these like terms right here. Negative 2n plus 12n, or 12n minus 2n is 10n minus 3. So that's what you should get from simplifying the first one. Now, we need to move on to the next one, which I said you have 2 options. You can distribute like we did before, or make a 1 by 2 box. I'm going to distribute. Put my little ones here. So 3n times 5n is 15n squared. 3n times negative 6 is negative 18n, or n to the first. Nothing to simplify with that. So now it said I wanted to add my like terms together. So I'm going to come down here. This is my first part, plus this is my second part. Now I'm just going to look for like terms and add. So I have 8n squared and 15n squared. Eight and 15. Oops, sorry. Remember, we don't change the exponents. Maybe I want to even underline those. Those are like terms. Then I have 10n and negative 18n. 10n and negative 18n is negative 8n. Dealt with that one. Dealt with that one. I have a negative 3. I've dealt with that one. I've dealt with that one. No like terms. So minus 3. So 23n squared minus 8n minus 3 is your answer.